Dear students, under the topic curl of a vector point function at a specified point, here we have the first problem. The question is find the curl of the following functions at the specified points. So we have two subdivisions under this topic. The first subdivision we will do now. So we have this is the given vector point function. In fact, we can take it as f vector for representation. So this is the f vector and we have to find the curl of this vector point function at this specified point. For that, first we should write the curl formula, that is the curl is given by nebula cross f vector, which is equal to the determinant of I vector, j vector, k vector, and dou by dou x, dou by dou y, and dou by dou z. Here we should write v1. v1 is the ith component. So this is v1. It is x square z. So x square z. Here v2. v2 is the jth component, which is negative 2 y cube z square. So y cube z square. And then here we have to write v3, which is the kth component, that is x y square z. So now we have to find the determinant of this value. So the determinant of this matrix is given by, so nebula cross f vector will be equal to, first we should take I vector. So I vector multiplied with this into this minus this into this, that is this has to be differentiated partially with respect to y first. So it will be dou by dou y of x y square z minus dou by dou z of negative 2 y cube z square, and then minus j vector multiplied with, so block this column and block this row, so it will be dou by dou x of this v3, so dou by dou x of x y square z minus dou by dou z of x square z, so dou by dou z of x square z plus k vector multiplied with, so block this column and block this row, so this into this minus this into this, so dou by dou x of negative 2 y cube z square minus dou by dou y of x square z. So we have written nebula cross f vector. Now we shall evaluate this. So this will be equal to, so nebula cross f vector will be equal to I vector multiplied with, what is partial differentiation of this with respect to y? X and z will become constants. So this is 2y. So 2xyz. And then minus into minus will become plus. And the partial differentiation of this with respect to z. So already we have a 2 over here. 2 times is 4. So 4 y cube z. And then minus j vector multiplied with partial differentiation of this with respect to x. So x is differentiation of x is 1. So y square z minus partial differentiation of this with respect to z. So the differentiation of z is 1. So we will be getting x square. And then plus k vector multiplied with partial differentiation of this with respect to x. We do not have an x term over here. So completely this will be treated as constant and so it will become 0. Minus partial differentiation of this with respect to y. Same here. Here we do not have y. So x square z become constants and we get 0. We have to evaluate the curl at a specified point. So we will take and write that the point is 1 minus 1 1. So we have to evaluate the curl at a specified point, which is 1 minus 1 and 1. So at the place of x we have to substitute 1, at the place of y we have to substitute negative 1, and at the place of z we have to substitute 1. So what we will get is I vector multiplied with, so here x we have to substitute y and z, so it will be 2 multiplied with x is 1, y is, so x is 1, y is negative 1 and z is 1, plus 4 multiplied with y cube, y is negative 1, so negative 1 cube multiplied with z, which is 1, and minus j vector multiplied with what is y square? Y square is negative 1 square multiplied with z is 1 minus x square, so 1 square. So that's equal to, we do not have I vector, I component, I mean k vector, because 0 minus 0, anyway this will completely become 0. So I vector multiplied with, so if you see this is minus 2, and what is minus 1 cube? It is minus 1, so we will be having minus 4 minus j vector multiplied with minus 1 square becomes plus 1, so 1 multiplied with 1 is also 1 only, minus 1 square, which is 1. And so that will be equal to I vector multiplied with what is minus 2 minus 4, it is minus 6, and j multiplied with 0. So this is going to become completely 0. Therefore, we will be getting the answer to be minus 6I vector. Therefore, nebula cross F vector at the given point is minus 6I vector. So this is how we have to evaluate the curl of a vector point function at a given particular point. In a similar manner, we will solve the second subdivision. So now here the second subdivision is this. This is the given vector point function. Let us take it, represent it as f vector, and we have to find the curl of this function at the point 1 comma 2 comma minus 1. So first of all we have to write the curl formula. So nebula cross f vector, which is the determinant of I vector, j vector and k vector. Here dou by dou x, dou by dou y, dou by dou z, and then v1, what is v1 over here? The ith component, which is xyz, and v2, which is the jth component, 3x square y, and v3, which is the kth component, that is xz square minus y square z. So we have to find the determinant of this matrix. So that will be equal to, so nebula cross f vector will be equal to I vector multiplied with, so block this column, block this row. So we will be having this multiplied with this minus this into this. So dou by dou y xz square minus y square z. So this into this minus dou by dou z of, so this into this. So 3x square y. Then minus j vector multiplied with, so block this column, block this row. So it will be dou by dou x of v3. So dou by dou x of xz square minus y square z minus dou by dou z of this vector v1. So x, y, z, and then plus k vector. So where is k vector? Here. So we have to block this row and this column. So we will be having dou by dou x of 3x square y minus this dou by dou y of x, y, z. So therefore, nebula cross f vector will be equal to I vector multiplied with, what is the partial differentiation of this with respect to y? This will become 0. Here you will have minus 2yz minus the partial differentiation of this with respect to z. We do not have z over here, so it will be 0 minus j vector multiplied with partial differentiation of this with respect to x. This will become 0 as we do not have an x over here, whereas here we have an x. The differentiation of x is 1, so we will be having z square alone over here. And then minus partial differentiation of this with respect to z. We have a z over here, differentiation is 1, so we will be getting xy plus k vector multiplied with partial differentiation of this with respect to x. So it will be 2x. So 3 2 times is 6. So 6xy minus partial differentiation of this with respect to y. So it will be xz. So we have to find the curl at this specified point 1 comma 2 comma minus 1. So let us do that. So nebula cross f vector at the specified point, which is 1 comma 2 comma minus 1, is equal to I vector multiplied with, here we will substitute the values of y and z, that is, this is x, this is y, this is z. So we will be having minus 2 multiplied with y is 2, so 2 multiplied with z is negative 1, minus j vector multiplied with z square, which is negative 1 square, minus xy, x is 1, y is 2, and then plus k vector multiplied with 6xy, so 6, x is 1, y is 2, minus xz, x is 1 and z is minus 1. And on simplification we get I vector multiplied with minus into minus becomes plus, and 2 times is 4. And here we have minus j multiplied with, so minus 1 square will be 1, and minus 2 1 times is 2, and so it will be minus 1. So minus 1 plus k vector multiplied with 6 2 times is 12, minus into minus becomes plus, 1 we have 12 plus 1 is 13. So further writing it in a proper manner, 4I vector minus into minus is plus, so j vector plus 13k vector. So this gives us the value of the curl at the given point 1 comma 2 comma minus 1. So I hope by now you would have understood how to find the curl of a vector point function at a given specified point. In our next video, we will learn what is an irrotational vector. So kindly follow the next video lecture. Thank you.